Here's a puzzle called Mystery Arrow One Box Puzzle by Maff. We're going to put the digits 1 through 9 in this grid. Digits along arrows sum to the circle, so if we discovered this was, uh, let's say 1, 2, 3, then this would be a 6. And it looks like all the arrows are sharing these two cells. Um, of rows, columns, and diagonals indicated by this question mark have the same sum. Huh. Okay, that's gonna be interesting. Yeah, so I don't know how hard this is. There's a decent number of solves on it already. I got this puzzle from the Sudoku testing submissions channel of the CTC community Discord. It was posted like 10 hours ago, the first thing this morning. Um, and at least for me, obviously, time zones and such, but for me, it would have been like, early morning on Sunday. It has 13 solves, so there's a decent number of solves, but it's not a ton of solves. It's probably not too difficult, just based on the fact that it's one box of a Sudoku grid. But yeah, we'll see. I'll put a link to the puzzle in the description down below if you want to give it a try. Let's hop into it. So the this arrow seems so, or these arrows seem so constricted. The minimum we could do is 1, 2, 3, 4, 5. But there is some leeway there I'm seeing. So that would make this 6. That would make this 6, 7, and 8. But of course we could still go one higher and have a 9. So yeah. But we have to have a 1 on here. We definitely have to have a 1 in one of these cells. Because if we didn't have a 1, then all of these would have to add to 9, and all of these arrows would have to be 2, 3, 4. So there must be a 1. Must there also be a 2? Yes, there must also be a 2. Because if we did 1, 3, the minimum we could... No, maybe not actually. 1... No, we don't actually have to have a 2. 2, 4, 5 works. And would be 6, 8, 9. Okay. But we couldn't have a 4 on here. 2, 3. Yeah, we couldn't have a... Yeah, the last one wouldn't work, yeah. So this has a 1, and it has a 2 or a 3 with it. And these are all maximum of 6. Yeah, okay, that makes sense. So should we look at maybe this column and see what options we have? We could do 15 maximum. If we did 4, 5, 6, it would be 15. But then would we have trouble hitting 15 in these other diagonals? Because these are going to be pretty big digits. These are going to be 6, 7, 8, or 9. These could be, if this was 4, 5, 6, this column, or sorry, this diagonal would have a little bit of trouble, I think. Because this would be a minimum of 6. And this couldn't even be a 6 because we literally just said this is a 6 over here. So this would be a 7, a 4. Oh no, maybe could this be a 3? No, but that's a complicated reason. 7, 7, 4. No, it would be 7, 4, 4. What am I talking about? 7, 4, 4. Uh, and also we couldn't reuse the 4th anyway. So maybe it's not a complicated reason. 7. This 7 couldn't even have a 4 here, actually. Because the 4 must be on the line with it. So if this was 4, 5, 6, this would have to be the 4. This would be 7. This would be a minimum of 5. This would be a 3. That would actually work. That would actually work. Okay, so what's the minimum for these? If we tried to do... We can't use 2 and 3 because one of these must be over here. But if we tried to do like 2, 4, 5, that would be 11. Then wherever we put the 9 would break. Is there any place that isn't part of it? Is there like a magic square we could... Or magic cell we could leave the... No. I was thinking maybe we could like put the 9 in a corner that's not in one of the marked places, but that's not something that is possible. So the 9's in it, so minimum of 12, maximum of 15. Yeah, because 9 and 1 and 2 would be the absolute minimum we could fit in a row. Or a column. Or a diagonal, I guess. So 12 minimum. Which doesn't really rule much out, because like this could be 9, 2, 1, I think. And this would be a 3, a 6, and that would be 15, or sorry, 11 here. Wait, let me do that math again. If this, because we started with 12. 9, 2, 1 would be 12. This would have to be a 3. This would have to be a 6. So this couldn't be a 9. That's a very specific situation that I just guessed does not work. But does it break on other diagonals? Well, this couldn't be 12 with 9. This couldn't be 12 with a 9. This couldn't be 12 with a 9. This can't be 12 with a 9. So the 9 must be up here if this was 12. Which doesn't work either because we need the 1. So I don't think it can be 12 either. Let me just go through that again. This one's easiest. To make 12, the 9 has to go with 1 and 2. There might be a better way of thinking about this, but thinking about the puzzle as a whole, I mean. But let's just look at 12 initially. So if this was a 9, this would have to go with 1 and 2. But we've said 1 must be over here, so therefore this can't be 9 if our sum is 12. If we look right here, this would have to be 9, 1, 2, but this would have to be a 3 then, which doesn't work. Then if this was a 9, we could go 2, 1 this way. And this is a little bit harder, but this would be 3, 6. And this sums to 11 instead of 12. So the sum can't be 12. But I think the better way of looking at this, so we have 12, 13, or 14. 12, 13, 14, or 15. And we just said 12 doesn't work, so 13, 14, 15. What digit could this be? Is it possible that this is also 6, 7, 8, or 9? If this is a 6, 7, 8, or 9, this would have to be... If this was a 6, 7, this could never be 8 or 9, is the first thing. Because these two digits would be way too large. So this is a minimum of 6 or 7. If this is a large digit, I should say. Yeah, if this is a large digit, this must be 6 or 7. This must be 6 or 7. This must be a 2. Which then breaks this line because 6, 7 requires there to be a 2 on the line. 6 and 7 requires a 2 and a triple that adds up to it. So this can't be a 6 or a 7. And it can't be an 8 or a 9. That means this means this is a 7, 8, 9 triple. And puts a 6 over here. Which means this must be 1, 2. Because we need to do 1, 2 adds up to 9, wherever that may be. Actually, wait, do we know that 6 must be, could this be a 6? 6 plus 7 would be 13. No, we said that because, yes, this would be 7, this would be 6, this would have to be the 2, and then, but we need this to be 1, 2, 4, or 1, 2, 4, in any combination, 1, 2, 4, but we just use the 2 here. Yeah, this can't be a 6. Okay, 6 is in here, which is going to match up with the 9. Well, I guess the 3 is not in here. This must be a 3. Because 1, 2, and 4 goes with 7, 5 goes with 8, 6 goes with 9. Not necessarily like in these rows, but just, in general. Okay, so we do have 15 as the addition. So this has to add to 12. This can't be a 6. This can't be a 9. So that means this can't be a 6. That puts a 6 here. Makes this a 9. Either of these work. This can't be a 9 anymore. If these add to 12... Wait, this adds to 15. This adds to 9. That's 24 total. So if this adds to 12, this... No, that's not what I'm trying to find. This adds to 12. This doesn't necessarily add to 12. This adds to 11 or 13. But this must add to 13. Yeah, that's the easiest way to do that. How do I add up to 15? It's just maximums. I was trying to do some algebra or something, and that's not what's needed. There we go. Not too hard, but a fun solve. Very satisfying, quick solve of just like looking at the options, ruling some things out. Yeah, I didn't need to rule out, 12 using the 9s. I could have just looked at this cell and like, what are the options? As soon as you start looking at the big numbers, the puzzle breaks, which then forces the biggest numbers over here, and forces this to be 4, 4, 5, 6. So I did waste a little bit of time there, but yeah, I'm not in any sort of competition. So anyway, thank you, Maff, for the puzzle, and thank you guys for watching.